Hello class. Today we are looking at section 5.2, factoring the difference of two squares. Turn to page 315 and look at the vocabulary. Difference of two squares. It says the binomial x squared minus y squared is called the difference. We know difference means subtract of two squares. X squared minus y squared. Because x squared is the square of x and y squared is the square of y, the difference of the squares of two quantities always factors into binomial conjugates. And we talked about the word conjugate back in chapter 4. What does the word conjugate mean? Think about that. Go to page 317. It talks about the sum of two squares. So make sure you read that. The binomial 25a squared plus 9b squared is the sum of two squares because it can be written in the form 5a squared plus 3b squared. If we are limited to rational coefficients, binomials that are the sum of two squares cannot be factored unless they contain a GCF. Polynomials that do not factor are called prime polynomials. And we know the word prime back in elementary school. We know prime means it can't be broken down. We know the word prime means that it's divisible by itself in one. So when we're talking about the word prime in factoring, that means that we can't break down that problem. Turn to page 318 and look at number 21. It says factor each polynomial. I have y squared minus 49. Now right here, this is a difference of two squares. And the reason I know that is because I can take the square root of y to the second and I can take the square root of 49 and it has a minus sign in between it. Now to factor this, we want to think about that for method. It gave me that term binomial conjugate. That means something. So when I see that word conjugate, I want to think about that for method. And if we remember from chapter 4 notes, when I see the word conjugate, the outside and inside equals 0 every time. So I only multiply first and last. When I see the word conjugate, the outside and inside is going to equal 0. So I only need to multiply first and last, and that's it. So when you see me factoring out 21, and if you were to, and we're going to check this one so we can see that the outside inside part gives me 0. Let's factor this. What's the square root of y squared? In my index, it is understood to be a 2 because I said square root. When I see the word square, I think of 2. The 2's cancel. I'm only left with y. So the square root of y squared is y. Or I can say, how many y's do I see? I see 2. I'm going to put 1 here and 1 there. What's the square root of 49? When I say square root, I'm asking you, what same numbers can I multiply twice to get 49? 7. And then we think about conjugates. We said that the signs are going to be different. And that's how I factor out 21. Now let's check our work to see if my math is even right. I can check this by using the box method or using for. If I use for, I'm going to say first. I'm going to say outside. I'm going to say inside. And I'm going to say last. What happens to those inside terms, the outside, inside? They equal 0. And I'm left with my original problem, y squared minus 49. These are conjugates, and let's go back over that definition. I know these are conjugate because everything is the same except the signs in the middle. And when I see a conjugate, the outside, inside equals 0. So I'm left with this part. So when you think about difference of two squares, another term, a perfect square. When you think of that term, you also want to think about conjugate. So a lot of vocabulary, but write it down and study over that. Conjugate, difference of two squares, perfect square, they all tie together. Look at number 25. I have 25 x to the fourth minus 81. This is also a difference of two squares because I can take the square root of the first term and the square root of the second term, and it has a minus sign in between the two. The square root of 25 is 5. 5 times 5 is 25. X to the fourth. What's the square root of 4? It's 2. So I have x squared and x squared. What is the square root of 81? I know 9 times 9 is 81. And then we think about that conjugate. Everything looks the same except the signs in between. Does the order matter? No. You can say minus and plus, or plus and minus. The sign order does not matter in these particular problems. Again, you can use your for method, but if I can identify these are conjugates, I only need to multiply the first. Properties of exponent rule says when you multiply, you add those exponents. So 5 times 5 is 25. 2 plus 2 is 4, right? 9 times 9, 9 times negative 9 is negative 81. And we know that's correct. So you can also check these very quickly to see if you did your math correctly. Number 33. Factor each polynomial. I have x to the fourth minus 9y squared. These are also a difference of two squares because I can take the square root of both terms. The square root of 4 will give me that x squared and x squared. Square root of 9 is 3. Square root of y squared is y. I know y times y is y squared. And then the signs will be opposite of each other. I can't take the square root of 3. I can't think of two identical numbers that will multiply and give me 3. So that's why I wouldn't break this down anymore. And again, it says difference. That's a plus sign. So that's another indicator to tell me I can't break it down as well. 35 says factor each polynomial completely. When I see that word completely, that's an indicator I'm probably going to have more than one step. Now, we talked about the new term. So far, we have talked about greatest common factor. We've talked about factor by grouping. When I'm looking at a binomial, I want to think about difference of two squares when I see binomials. If I look at this, can I take the square root of 8? Can I think of two of the same numbers that will multiply and give me 8? No. Well, what about 32? No. I can break down x squared and y squared, but I can't break down those coefficients. But I do see something that we talked about last time. I can find a GCF. What can I factor out of 8 and 32? Well, I know 8 times 1 is 8. And 8 times what number will give me 32? Let's think about that. Can 8 times some number give me 32, or do I have to go smaller? Well, let's break down 8. I know 8 times 4 give me 32, so let's try it. So we're going to factor out of 8. 8 divided by 8 is 1, so I'm left with x squared minus 32 divided by 8 will give me 4, and I'm left with y squared. I can do a quick self-check. 8 times x squared is 8x squared. 8 times negative 4y squared is negative 32y squared. So quick self-check. The question says factor completely, so that's an indicator that I probably have to do another step. Okay, so look at this. Can I take the square root of this binomial? I can. I can take the square root of everything. Square root of 4 is 2. My last step, I got 8. I know x times x is x squared. I know y times y is y squared. I know 2 times 2 is 4. And the signs will be different. Because when we're doing the difference of two squares, we're going to see two conjugates. And again, conjugates is everything looks the same except that sign in the middle. Number 43. I have 4a squared x minus 9b squared x. Now, when I look at this one, I can take the square root of 4a squared, 9b squared, but I can't take the square root of x. I can't find the same letter, multiply it twice, and get just x. So it's not ready for me yet to do my difference of two squares. But I can go back and think about my greatest common factor. This is a binomial, and the common factor of the two is x. So I factor out of x, and I'm left with 4a squared. Bring down the minus. I'm left with 9b squared. Now, in the parentheses, I'm looking at a difference of two squares. I have x, write down my parentheses. Square root of 4 is 2. Square root of a to the second is a. Square root of 9 is 3. Square root of b to the second is just b. And the signs will be opposites of each other. Again, the order doesn't matter. It can be plus, minus, or minus plus. It doesn't matter. Just make sure they're different. When you're dealing with the conjugates, make sure they're different signs. Number 47. It says factor each polynomial completely. I have a to the 4th minus 16. Now, I can take the square root of both parts. So let's do that. Square root of 4 I know is 2. So I got a squared and a squared. Or all you're doing is splitting that a to the 4th in half. So 2 and 2. Square root of 16 is 4. And then the signs are going to be different. Now, we talked about difference of two squares. I can also take the square root of the second parentheses. This one is not a difference because plus means sum, not difference. So I can only break this one down again, and this has to stay the same. So I'm going to bring down a squared plus 4, and I'm going to factor again. A times a is a to the second. The square root of 4 is 2. And my signs will be different. And you can multiply. We have done an example of these on our homework. So you can multiply these two first. And then it'll be a 3 by 2. And you can use box method and multiply this out. And then you'll get back to that same expression. Look at number 56. We have 2x to the 8th, y to the second, minus 32y to the 6th. When you're factoring, we've talked about greatest common factor. We've talked about factor by grouping and factoring out the difference of two squares. So we've already talked about 3 factoring methods already. But the first method you want to always think about first is, does it have a GCF? This is a binomial. Let's review. What would be my degree? I have 8 plus 2 is 10. And then I have 6. My degree is 2. My degree is 10. My leading coefficient would be 2. But I notice I can't take the square root of 2. I can't take the square root of 32 and find a integer. And we know integers are the positive whole numbers, negative whole numbers, and 0. So I cannot find two whole numbers that can multiply and give me 2 again. The same two whole numbers. I can't find two of the same whole numbers to multiply and give me 32. So it's not a difference of two squares. But I can find a GCF. 2 and 32, I can factor out a 2. They do not have an x in common, but they do have at least 2 y's in common. And that's my GCF. When we divide, I'm going up and down. So I'm dividing. I got to subtract those exponents. 2 divided by 2 is 1. X to the 8th, I bring down. Y squared, I don't bring down. Minus sign. 2 goes into 32 how many times? 16. 6 minus 2 is y to the 4th. Now you want to look at what's inside the parentheses. Is this a perfect square? It is. I can take square root of x to the 8th, 16, y to the 4th, and it got a minus sign. It's good. I'm going to write down 2y squared. Go ahead and do your parentheses. And space it out pretty good so you have plenty of room. Break this in half. I got x to the 4th. Square root of 16 is 4. Break y to the 4th in half. So I have y squared. And then the sign's going to be different. This is not a difference. That's a sum. So you can't break this one down anymore. But this one is still a difference. And I can take the square root of x to the 4th and 4 and y squared. So I can break it down one more time. I'm going to write down 2y squared. Bring down x to the 4th plus 4 y squared. Set up 2 more parentheses. Break this in half. I have x squared. Square root of 4 is 2. Break down y squared is y. And the signs are going to be different. And that will be my final answer. Completely factored out. This is my final answer. And you can check it, but you'll be multiplying a long time. But you can check it to make sure that it is correct. $57 would be a good one to try. Let's try that one. I have a to the 3rd minus 9a plus 3a squared minus 27. The first thing you want to do is identify how many terms you have. I have 4. So when we see 4 terms, we think about factor by grouping when we see 4 terms. Do I have a GCF? These I can factor out of 3, but I can't do it here. These 3 I have an A, but no A there. So I do not have a GCF. So I do want to think about that factor by grouping. Thinking about factor by grouping, I want to match these 2 together and then pair these 2 together. Looking at the first 2, what do they have in common? I can factor out an A. 3 minus 1 is a squared. Minus 1 minus 1, no a. Bring down just that 9. Whatever this sign is, write it down. Next, I can factor out from these 2 terms a 3. 3 going to 3 once. I'm left with a squared. 3 goes into 27 9 times. If I did my factor by grouping correctly, my parentheses will match. And they do. So I feel good about that. We have to group it again. So looking at this part here and this part here, what do they have in common? They both have a squared minus 9 in common. What did they not have in common? It was a plus 3. I now see a difference of 2 squares. I can take the square root of a squared and the square root of 9 and bring down that a plus 3. A times a is a squared. 3 times 3 is 9. Plus minus, they look like conjugates, so I am done with that one. One thing I do want to notice is I see a plus 3 twice. So can I finalize that answer another way? I can. This is finalized, but I can clean it up a little bit more to make it look a little better. I see a plus 3 twice. And then I see a minus 3. And if you notice, it's still in some type of standard form. I got the 2 and then the 1. It's in the standard form still. And that would be your final answer that you would type in. Look at number 67. I have a squared plus b squared. Is this a difference of 2 squares? What does the word difference mean? If you go back to page 317 and read what we said about the sum of 2 squares, it will tell you that binomials that are the sum of 2 squares cannot be factored unless it contains a GCF. So if I look at a squared plus b squared, do we have a greatest common factor? We do not. And it says polynomials that do not factor are called prime polynomials. So because this does not have a GCF and it's an addition, it is prime. I cannot break this down. Number 84. And 84 is a little different, but we're going to try it. I have 25 times a minus b squared minus 16. This is a difference of 2 squares because I can take the square root of 25. I can take the square root of a minus b squared, okay? And to show you that, I have a minus b squared. And the index understood to be a 2. The square root of a minus b squared is just a minus b. So I can take the square root of a minus b squared. And then I know the square root of 16 is 4, and I have a minus sign. But it looks so ugly. So when it looks ugly, I can do substitution. I can let x equal a minus b. Don't use the same letters. Don't use a or b because a and b is in the problem. Use a different letter other than a and b. So I'm going to use x. So I'm going to say 25x squared minus 16. So what I did was I used substitution. I let a minus b represent x. So if you want to do a side note, x equals the a minus b. So we're using substitution. Now, does it look easier to factor now? Let's see. I have 5, x, square root of 16 is 4 and 4, and then the sign's going to be opposite of each other. Pretty easy. But x was not an original problem, a minus b was. So we do have to do a little more work in the end, but it's not anything too complicated. Now let's look at this. We have 5, and I'm gonna change it up a little bit. I'm gonna use a bracket instead of parentheses. It's okay. If you don't like the bracket, do all parentheses. So I have a 5, and then where x is, I'm gonna do a minus b. And then bring down that plus 4. And the brackets just help do a little separation for me. But it represents the same thing, multiply, so we're good. I have 5. Where x is, I'm going to substitute x with a minus b. And then I'm going to bring down the minus 4. Do not overthink this problem. Just take your time and work it out. My final answer. And I'm going to go back to parentheses now. 5 times A is 5A. 5 times negative B is minus 5B. Bring down to plus 4. They have absolutely nothing in common, so I cannot combine any like terms here. Times 5 times A is 5A. 5 times negative B is negative 5B. And then minus 4. And then close that parentheses. And that will be my final answer for number 84. You try number 83. You're going to set it up the same way. Use a different letter other than the Y. Use another letter. So you can do, and on this one now, don't use, on 85, don't use X either because you have X and Y in your original problem. So use another letter like T and Tom. Use something different other than X and Y. That way you won't mix up the letters. Okay, so try number 85 and see how you do on it. And let me know if you need any help with anything else on this section. Factoring is very tricky, so it is so important that you study these rules. We have talked about greatest common factor so far, factor by grouping, and the difference of two squares. And we've also talked about when a polynomial can be prime, which means I can't break it down. So please study those rules and let me know if you need any help.